Hi and welcome to this video lesson. My name is Charles Agbani. In this lesson, we'll be looking at inverse proportion. In our previous lesson, we've looked at what proportion is, the different types of proportion, and we also focused on direct proportion. So in this video, we are going further to look at inverse proportion. So you can check out the previous video that we've uploaded on this platform, or you can just simply go to the playlist of this YouTube channel to check the playlist on ratio, rate, and proportion. You'll see all the videos that we've done on these related topics. Okay, so what is inverse proportion? In this proportional relationship, when one ratio increases, the other ratio decreases. Okay, unlike what we've looked at in direct proportion, where as one ratio increases, the other ratio also increases. In inverse proportion, an increment in one ratio means a decrease in the other ratio. For example, if one boy is able to clear a field in 2 days, two boys will be able to clear that same field in 1 day, right? So the more the number of laborers working on the field, the less the time it will take to get the job done. So that situation is an example of an inverse proportion. As the number of workers are increasing, the time it takes for the work to be done is decreasing. So now let's look at the situation between two ratios. C is inversely proportional to N. How do we know it is inversely proportional to N? Inverse means 1 over. You flip it, right? So 1 over N means inversely proportional to N. If this is not a fraction, if you just have C is and this. So this is directly proportional to N, but this is inversely proportional to N because C is a numerator, N is a denominator, so they are inverse of each other. So this is the way of writing that down. And remember, we always change the proportionality sign to an equal to sign. So in this situation, when we change it, we have C is equal to Kn, right? But we can't get this because N is a denominator. Once we put K is going to be a numerator and N will be a denominator. So that's why we have C is equal to K all over N. In direct proportion, we have C is equal to Kn. In inverse proportion, we have C is equal to K all over N. That's the difference when solving questions on direct proportion and inverse proportion. Okay, so let's solve an example. Okay, so let's look at this example. We are told that if V is inversely proportional to W and V is equal to 120 when W is equal to 6, find V when W is equal to 9. So this is a question on inverse proportion, right? So we can simply write V is inversely proportional to W, right? V is inversely proportional to W. So W is a denominator. But we have to remove the proportionality sign. So V is equal to K all over W. Okay? So we are told that when V is equal to 120, W is equal to 6. So for A, so when V, so we have 120 is equal to K all over 6. So remember, 120 is the same thing as 120 all over 1. So we can cross multiply. K multiplied by 1 is going to give us K is equal to 120 multiplied by 6 is going to give us 720. Okay, that means the value of K is equal to 720. So we can write this relationship as V is equal to 720 all over W. So this is the relationship between V and W. Okay, so now we can find V when W is equal to 9. So V when W is equal to 9. So V is equal to 720 all over 9. 720 divided by 9 is going to give us 80. So V is equal to 80. So we're able to find the value of V when W is equal to 9 because first we calculated the value of the constant of proportionality in this inverse proportionality problem, right? So don't mistake the process of calculating inverse proportion and direct proportion. In inverse proportion, we have 1 all over the other ratio. Okay, let's look at the second example before I write the classwork. Let's look at this example. We are told that if y is inversely proportional to x, and when and y is equal to 2 when x is equal to 3, we're expected to find y when x is equal to 6. Okay, so this is an inverse proportionality problem. So we can say y is inversely proportional to x. This means y is equal to k all over x, right? So when y is equal to 2, x is equal to 3. 2 is equal to k all over 3. 2 is the same thing as 2 over 1, so we can cross multiply. K multiplied by 1 gives us k is equal to 2 multiplied by 3 gives us 6. So this means that k is equal to 6. So now we can write the relationship between y and x. Okay, so y is equal to 6 all over x. So that is the inverse proportionality relationship between y and x. Now we're expected to find y when x is equal to 6. So y when x is equal to 6. So we have y is equal to 6 all over 6. 6 divided by 6 gives us 1. So y is equal to 1. So now let's really look at this inverse proportionality relationship. When x was equal to 3, y was equal to 2. But when x increased to 6, so x increased, what happened to y? Y had to decrease. So this is the relationship we are talking about. When one value is increasing, the other value has to decrease. So that shows an inverse proportionality relationship. If you look at the examples we did for direct proportion, you will see that when one value increased, the other value also increased. Okay, so that's the difference. So now I'm going to give you the assignment. Get it done. Send it to the, if you're in the WhatsApp group, send it to the class coordinator or my assistant. Then if you're not in the WhatsApp group, just leave the answer comment in the comment section. Okay, so this is the simple question that you have to work on. So try out this simple question that we have on the board. In our next lesson, we're going to be looking at joint proportion. So we've looked at direct proportion and inverse proportion. Our next lesson will be on joint proportion. Thank you for watching till this point. Don't forget to like the video to support this platform, subscribe to this YouTube channel, and share with your friends that would like to learn this same topic. See you in the next video.